In this problem, we have a cosecant squared t is equal to 3. So what we can do is we can either set this equal to 0 and factor, or we can take the square root of both sides. And remember that in a squared function, the cosecant of t could equal a positive square root of 3, or the cosecant of t could equal a negative square root of 3. And in this case, since we are not as familiar with the cosecant function and its unit circle values or its angular values, we're going to use the fact that the sine of t is equal to the reciprocal 1 over the cosecant of t. We can flip over the cosecant value and have 1 over the square root of 3 and say that's the sine of t, and the reciprocal of the right-hand side and say that's the negative 1 over the square root of 3. So now we have our two equations that we need to solve. And we draw our circle, our unit circle, and we mark this is also equal to a negative square root of 3 over 3 if you multiply the numerator and the denominator by the square root of 3. The square root of 3 is a little less than 2, so this is a negative right about here. So this line right here will be y is equal to a negative square root of 3 over 3. And we get, with the inverse sine, the principal solution will give us this angle, this negative angle right here. And the symmetric solution will give us this angle, pi minus our principal, and it'll be this one. So our first solution is t is equal to the inverse sine of negative root 3 over 3. Now, if this angle right here is a solution, then every single one of its coterminal angles is a solution, whether you go around in the positive direction or around in the negative direction. And that would just mean adding a number, k, times the period, 2 pi, to it. And we'll let this number k be an element of the integers. So that means k is any integer value. If k was 0, we'd just get this initial value right here. If k were 1, we'd get all the way around and 2 pi plus that initial value. If k was negative 1, we'd go around clockwise and get the inverse sine of the root 3 over 3 minus 2 pi, and so on. So the symmetric solution then, t symmetric for this one, is equal to pi minus the inverse sine of negative square root of 3 over 3, but it's also plus k times 2 pi, because every angle that is coterminal with this point right here on the circle will also give us this same solution, the sine. For our second equation to solve, we need to look at over here, where the sine value is equal to a positive square root of 1 over the square root of 3, or a positive square root of 3 over 3, which is up here somewhere. And we'll just label it as y is equal to the square root of 3 over 3. And so right here is the inverse sine. So t is equal to the inverse sine of the square root of 3 over 3. And again, we'll add k plus k times 2 pi to it. So then we get a symmetric solution by taking pi minus the inverse sine of the square root of 3 over 3 plus 2 pi k. So again, all the coterminal angles. So this is the symmetric solution over here. See this angle right here, let's use a red. This angle right here, this small angle, is the inverse sine of the square root of 3 over 3. And this angle right here is also the inverse sine of the square root of 3 over 3. So if this right here all the way to here is pi, then pi minus the inverse sine of the square root of 3 over 3 will take you right to here. So these are our 4 solutions. So let's write them down, where k is an element of the integers. And you can generate solutions, as many solutions as you want, by letting k equal values like -1, 0, 1, and so on.